Hi, I'm Ivan. I'm a solution architect at Harper, and I do these weekly videos to share with you what I've been learning as I go and tips and tricks on how to use Harper to solve some of your most challenging business problems. So learn with me as we go, enjoy what we're about to see, and let me take you on a little adventure with real-time pub sub using Harper. So if you've watched any of these videos in the past, one of the things you see me focusing on is our MQTT and real-time pub sub support. But one of the things that's really important to know about Harper is that our real-time pub sub support isn't just limited to MQTT. So let me share my screen and show you a little bit about what we have documented, and then I'll take you through something that a little demo that you can find on GitHub as a starting point to show you how the various interactions and pub sub protocols that we support work. So what you see here on the left is the docs for Harper from our website. You can see this is our real-time pub sub. And we have protocols listed here. We have MQTT, WebSockets, server-side events. So these are all sitting here. We also, although it's not considered real-time, support the REST interface where you can do standard REST calls to get the status of data that's in Harper. So as long as in your config.yaml, you've set REST to true, you have REST access to any resources that you have in your Harper instance. So you can see here, again, I mentioned we have MQTT, WebSockets, and server-side events. One thing that I will show you on GitHub. So one of the things I did, if you remember our last video, I was showing you how the interoperability between all of these things works. So if you go to this MQTT Getting Started GitHub repo, it has a Harper deployment. You can go into this directory and do Harper dev dot, hit enter once you have Harper installed, and it will run the server. And then in the client directory, it's got a bunch of scripts using MQTTX, the binary MQTT pub sub app programs that are available on all the platforms. It's got Node.js and it's got Python. If we look in here, let's look in the Python directory. We've got an HTTP publish script, which does the RESTful publish or post. We've got the MQTT publish, which uses MQTT to become a publisher and send events. We've got subscription with MQTT. We've got server-side events or with the subscribe, because that's only subscribe. You can't publish on that. And then we've got WebSockets publishing and subscribing. And we have the same thing in the node directory. We have the same set. And the reason I point all that out is because using this set of scripts here, test and run all, what you can do is you can yourself run a full interoperability test across all of these. So if I go down here to the README, which is where I thought I was, clear instructions to show you how to run all this, an overview. And what you'll see down here is a matrix of what happens when you run the test. So if you run the publishers are in the column and the subscribers, publishers are in the rows and the subscribers are in the columns. So you can see when you send Node.js MQTT, it's received by all of the different subscription, including MQTT, WebSockets, server-side events in both Python and Node, and the MQTT binary. When you use WebSockets to publish, it's the same thing. The interoperable protocols that I'm talking about here that Harper does natively, which is super powerful, is if you publish via MQTT, you can subscribe via WebSockets servers and server-side events. And if you subscribe via MQTT and server-side events, you can publish via WebSockets. So all of these things work across the different protocols because within Harper, we do it all related to pub sub on the resource natively inside Harper. Same thing with an HTTP put. Create a resource, you subscribe to it through any of these protocols, and you make a RESTful call to insert something in that table, you're going to get an event via real-time pub sub. That's really handy, but it's the foundation of what I want to show you in this week's video. In this week's video, we're going to do what I have over here on the right-hand side of the screen. So the brown box is a web browser. It's going to connect to my Harper app that I've got deployed on port 9926. It's going to connect to an LED sign, one like this, which if I hit the reset button, you can watch it reboot and it's going to tell you its address. So it's connecting to Wi-Fi. The IP address didn't scroll by because it eclipsed by it being ready. It's now sending the ready sign. And so if I come over here, this is me connecting to a different sign that's right over there, but it's the same thing. This is me connecting to port 9926. You can see the user interfaces look almost identical. That's on purpose, right? We want these things to look the same. So let me connect this to the right Wi-Fi port for this sign that I have posted. You can see it is going to be, I think, 46 should be the port or the last. There you go. So now we're on this sign, which has a hardware address and a device ID that ends there. Here, we will switch to that sign. So now we're looking at that sign. And I'm going to show you some of what this means in the back end. But basically, I've got a web browser. I've shown you how it's connected to 9926, the Harper app. I've showed you how it's connected to the sign. It doesn't match the README, but the address is irrelevant in the diagram. The LED sign is also connected to the Harper app via MQTT, as is the other sign that's over my shoulder, which I'm going to reboot because it's got some annoying little lock on it. You can see that sign come up. So I've got the two signs, both connected to Harper. One I'm connected to via the browser. The other browser I'm connected to the actual app. Now, what does that mean? When you look in here inside my app, I've got my topics table that we had before, and I've got these topics: LED sign, sign ID, brightness, LED sign, sign ID, message, power, status. That's the one sign. 2FE598 is over there. 8B1EFC is the one sitting on my desk. And you can see this is what they have on them. They've sent their latest data. And now if I come in here to the web browser connected to the actual sign and I hold it up and I say, whoop, you'll see the web browser is connected directly to it and it changes the sign. That's exactly what you'd expect because this web page is being served off of the actual controller driving the sign. But look, it actually sent an MQTT message to our app and updated the state in the app right here with a timestamp. How do I know that? Because if I come over here and look at Harper, it's showing current message is old because it's from the other device. But if I go in here and I say hello, and I spell it right, and I hit send, now this browser tab is connected through Harper. So what it's doing is it's injecting hello via a REST call into the table. And when the table registers the change, it's publishing an update via MQTT to the sign. And that's what's showing up there. And the browser is checking via status and it's seeing that the current message is hello. So we've got a full round trip from both browsers through the device to update the status on what's going on. And the way we're doing it is our view application is subscribing via server-side events to the table, and it's publishing when I touch the controls in the interface through the REST interface with a put. Both of those things are modifying the table from the web app. When the table is modified, then it sends out, it publishes events to the subscribers via MQTT. When we go the other route and we go directly to the device and we modify the device, it's sending an event via MQTT to our Harper app, which natively gets parsed out of MQTT and injected into the table. And the table that it registers a change, and it sends a publish notification to subscribers via server-side events, WebSockets, MQTT, and all that. And that goes up to the app. So what we have is we have basically a model where you think of your resource or your table as being this awesomely trackable entity that you can do pub sub on the table, and you can do pub sub on the table with any of these protocols. You can use WebSockets, you can use server-side events, you can use RESTful injections to change the state, and then you can use MQTT to do pub sub. This basically creates an incredibly rich ecosystem of how to do that. Now, how does the code work? I'm glad you didn't ask, because you can ask. I'm recording. What I have in my schema.graphql is I have what we were looking at before. I have a single table, a topics table. I'm exporting it as blank, which registers it as the root endpoint for a bunch of stuff for MQTT. So devices that don't know anything about Harper can connect, and that just works without any extra effort. I've had to do one thing, which is in my resources.js, I had to export the const topics to point at the table.topics. The combination of these two configurations make the application able to come in, and I can serve the content that I've published, the index.html, the fav icon, the logo that you see on the app here, all of the different assets that have to be delivered. I can deliver via HTTP on port 9926, and at the same time, my HTTP put and get REST calls can go across 9926, and they land at the right endpoint to update the table. That's what this configuration has enabled, and it works flawless out of the box. It's extremely elegant. All right, so that was a whole bunch of stuff on MQTT and interoperability. We're coming kind of to the end of the arc on real-time pub sub. The next thing I want to do is basically finish out the plugin I showed you that will allow you to run Harper. One thing I can show you that is handy dandy, is doing this configuration. Standard tools like the MQTT Explorer just work against Harper, and they show you the topic tree and the topics and the values. So the same thing that you see here, you see here, right? Here's a table with a topic updated at value. If I look at it here, here's the topic, the value, the timestamp here is arbitrary, and updated at value is what we've got. So standard tooling works. So what I'm going to do next is integrate all this information into the MQTT interop plugin that I'll push up to GitHub. That plugin will add essentially the community conventions around $sys. So if I say sys somewhere in here, I should see $sys. So $sys is the server side sort of topic table. I'm going to try to map that to our internal Harper analytics because it's the same data. It's just being served to different endpoints via different tools. And so I'll finish up the interop plugin. I'll map the sys table to our internal analytics. I'll get that published on GitHub. And between the MQTT getting started, the app with the LED sign, and the broker plugin, you should have a complete set of tools that will help you wrap your head around how real-time pub sub works in Harper and build nearly anything that you want to build if you need to. If it isn't enough, join us on Discord, come ask questions, feel free to jump in, try the projects. If you run into issues, file requests on GitHub or ping us on Discord, and I'll be happy to help with anything you're having any issues with it. I'm going to leave you with that architecture diagram and just finish with Happy New Year. It's been a wild ride so far. And in 2026, you can expect to see a lot more really cool content coming, not just from me, but from the rest of the team at Harper. Austin's doing a ton of great DevRel work. The engineering team is just delivering and driving a relentless roadmap of innovation and cool solutions. And I will continue to share with you what I'm learning as I'm going. And we can just keep building cool stuff on Harper. That is what we want to do in 2026. All right. Stay tuned for more cool stuff and have a great week.